17.5 AP, this is when, how can we affect a solid to maybe dissolve faster or more? So this is what's called factors that affect solubility. We got some learning targets here. Identify the solubility of a salt and the value of KSP for the salt based on the concentration of the common ion already presented in solution. Okay, so this is when we're taking KSP, and we're going to do a little common ion effect too, like we did at the beginning of the chapter. So the solubility of salt, very important here. The solubility of the salt is reduced when it's dissolved into a solution that already contains one of the ions present in the salt. So AKA, when you have a common ion effect going on, the solubility of the salt, the solid, is reduced, okay, which means you're not dissolving as much as you were when it's dissolved in a solution that already contains one of the ions present. The impact of this common ion effect of solubility could be understood, and there it is again, Le Chatelier's principle, okay, which you're going to see one of those in just a second. The solubility of the salt is pH sensitive when one of the constituent ions of the weak acid or base. This effect can be understood qualitatively again, Le Chatelier's principle, okay, which we'll look at that also, pH down here, okay. Factors that affect solubility, okay, so we're talking about solids dissolving, okay. 3 factors. Number 1, common ion effect, pH of a solution, and the presence of a complex agent. I'm not going to talk too much about this one because AP does not test on this one too much. And what I mean by too much is I'm not even sure if I've ever seen it, okay? But that is 3 that come from the book, but these are the 2 that AP are talking about. So right here, common ion and pH sensitive. That's it. That's all we're going to talk about because that's the 2 learning objectives that they mention, okay? So number 1, common ion effect. The solubility of a slightly soluble, okay, salt. So we are talking about a salt, but does not dissociate completely, okay, is decreased, okay, which means dissociates even less when a common ion is added, okay. So we can apply Le Chatelier's principle to this, which means we're going to have to explain. So let's say we take that same example, calcium fluoride. We have our equation. Let's say we have more ions of fluorine added, okay. We have more fluorine of ions added. So this is kind of like what my teeter-totter looks like. I have just added more fluorine ions. And how would I add it? By adding a common ion. And I don't care about the sodium. Sodium's not part of this equation. It's the fluorine. The equilibrium shifts to offset this increase. So which way will I have to shift? I'm going to have to shift my reaction, and therefore calcium fluoride, I'm going to form more of him. And because I form more of him, that means he's going to dissociate even less, okay? So to reestablish equilibrium, ladies and gentlemen, my calcium fluoride is going to be formed, which means more precipitate is going to happen. And by adding that common ion, I shift the equation to form more of that solid. And remember, it's all about this K to Q. So to reestablish equilibrium so that Q equals K. It's all about this. Because by you adding a common ion, you applied a stress. That's Q. Now how do you fix it? It's K. All right. How will solubility affect pH? Okay, so now I got to give you an equation that either has H or OH in it. And it's going to be the OH in here. So again, so this right here, common ion and solubility of pH. So again, we apply Le Chatelier's principle. Let's say we have magnesium hydroxide. Ooh, it's been a day. Magnesium hydroxide. And this, technically, I don't want you to think of, he is not a strong base. Okay? Because remember on the periodic table, group 2, you have beryllium, you have magnesium, but it's these three, the last three, they are strong bases. So calcium, strontium, barium, those are the strong bases, okay? So I got Mg and I got two OHs. If I remove some OH, okay, so what's my teeter-totter look like? If I remove OH, it looks like this, okay, because I lost some OH. Then the equilibrium shifts towards the right, and my MgOH will actually dissolve more, okay? So my equilibrium will shift, and my solid will actually dissolve more. So by doing that, what am I producing? I'm producing more OH. And how is that affecting pH? Well, if I'm increasing my OH concentration, what's happening to pH? My pH will increase. And if my pH is increasing, I'm sorry, hello, almost did a boo-boo. If my OH is increasing, my pOH is increasing. And that means my pH is decreasing. Okay, because remember, if one goes up, the other one goes down. So as my pH decreases, okay, my H concentration increases, and the solubility of that MgOH increases. Because remember, I'm dissolving him more, okay? And if my concentration of OH increases, my pOH increases. That means my pH decreases, and that means I'm making it more acidic, okay? And that's why my H increases. There's a lot of explaining here, okay? We're just trying to figure out how it works, okay? So by doing that, because I'm making it more acidic, my H concentration will increase, okay? The effect of pH on solubility can be dramatic. The effect is more significant if one or both ions involved are at least somewhat acidic or basic. That's why we have to use OH for this. If it would have been like calcium or fluorine, I can't get pH from calcium and I can't get pH from fluorine. So that's why we have to use this for somebody that's slightly acidic or slightly basic. So in general, solubility of a slightly soluble salt containing basic ions increases as pH decreases. The more basic the anion is, the greater the effect. Okay? And how will you know if something's more basic or not? Because that means that pH will be definitely greater than 7. So the more basic it is, the greater the effect. Okay? In 17.6, you guys are going to watch AP Daily 7.12, okay? And if you want, you can take the notes here, and then when I assign 7.12, you can upload those notes there, okay? So right here, there's no video from me because I want AP Daily to help you with that, okay? 17.7, that's the lab final, okay? So we do not discuss this because it's after the actual lab, okay? And you guys are going to finish it off with one titration pass AP question. This is an actual pass AP question. And you guys are going to look at the video from 8.4 right here, 8.5, and answers right in the beginning of that video. Okay? Chapter 17, ladies and gentlemen, small chapter, but it's a beast. See you on the next one.